Have you ever walked into a room and instantly felt like you were being watched? Or felt a sudden, unexplainable wave of dread seconds before something went wrong? That's not paranoia. That might be the faint echo of a superpower still buried inside your DNA. Here's something most people never think about. Your genome isn't just a record of what you can do. It's also a graveyard. Buried inside your DNA are hundreds of genes for senses your ancestors almost certainly relied on. Senses that modern humans have quietly stopped using generation after generation, until the genes that built them simply broke. Geneticists have a name for these broken instructions. They're called pseudogenes, genes that still exist, still sit right there in your chromosomes but no longer function. And when scientists count them up in the human genome, the numbers are honestly staggering. Today we're going to look at exactly what some of those dormant genes were once capable of, and ask an unsettling question. If the modern world disappeared tomorrow, is there any chance those ancient instincts could wake back up? For most of human evolutionary history, survival didn't depend on reading spreadsheets or checking phones. It depended on picking up on signals most of us have completely lost touch with. Take smell. Humans actually carry close to 800 olfactory receptor genes. The genes responsible for detecting different odor molecules. That's a massive genetic toolkit for scent detection. The problem is, geneticists studying this gene family have found that roughly half of them, some estimates put it above 50%, are pseudogenes. Broken. Switched off. Present in your DNA, but functionally useless. For comparison, dogs and mice retain a far higher percentage of working smell-related genes, which is a big part of why your dog can find crumbs you didn't even know you dropped, while you can barely tell what's cooking 2 rooms away. Why did we lose so much of this? The leading theory among researchers is almost poetic. As our primate ancestors evolved excellent color vision, sight gradually took over as the dominant survival sense, and smell became less critical to staying alive. Genes that aren't actively needed accumulate small, harmless-seeming mutations generation after generation, until eventually, they stop working altogether. And smell is just one example. Across the human genome, this same pattern of quiet abandonment repeats itself again and again, sense after sense, system after system. Genetic tools our ancestors likely depended on, slowly going dark. Now here's where things get genuinely strange. In migratory birds, scientists have identified a gene called cryptochrome, part of a family called cryptochromes, that appears to play a role in detecting Earth's magnetic field. It's one of the leading scientific explanations for how birds can navigate thousands of miles without ever getting lost, essentially using an internal compass built directly into their biology. Humans carry cryptochrome genes too. And for years, this has fueled a genuinely fascinating scientific question. Could human beings have once had, or still retain some trace of, a biological sense for magnetic fields? I want to be careful here, because this is exactly where a documentary can accidentally oversell the science. The honest answer is, we don't know, and most researchers are cautious about it. Unlike birds, where the evidence for cryptochrome-based magnetic sensing is well studied and fairly well supported, evidence for functional human magnetoreception remains thin, contested, and far from proven. A small number of controversial experiments have hinted that human brains might respond to changes in magnetic fields at some subconscious level. But this is genuinely one of the more speculative corners of sensory science, not settled fact. What is settled is this. The genetic hardware related to magnetic sensitivity in other species does exist in the human genome too. Whether it ever did anything useful for us, or whether it's just evolutionary leftover baggage from a distant shared ancestor, is one of biology's open questions. So why would evolution let any of this fade, if these senses sound so useful? Because every biological system has a cost. Maintaining a hypersensitive nose, or a magnetically tuned brain, or heightened awareness of subtle environmental danger cues takes energy and neural real estate. And when a species starts relying more heavily on something else, like complex social cooperation, tool use, and increasingly sophisticated analytical thinking, evolution tends to reallocate resources toward whatever's working best. This is sometimes described as a trade-off between primal sensing and abstract reasoning. As hominin brains grew larger frontal regions associated with planning, language, and complex problem-solving, there's a reasonable evolutionary argument that older, more reflexive sensory systems became comparatively less essential to survival, and so natural selection stopped strongly maintaining them. It's important to say clearly, this doesn't mean modern humans are worse than our ancestors, or that we've lost something tragic. It means we specialized. We traded breadth of raw sensory input for depth of analytical processing, and that trade is arguably the single biggest reason humans built civilizations while no other species did. But it does mean there's a version of the human sensory toolkit, encoded right there in your chromosomes, that you will simply never get to experience. So here's the genuinely eerie part. A pseudogene isn't necessarily gone forever, in the way a deleted file is gone. It's more like a machine that's been unplugged rather than destroyed. In rare cases across the animal kingdom, researchers have documented seemingly dead genes regaining partial function again through further mutation. A process sometimes nicknamed a gene coming back from the dead. That doesn't mean humans are one lucky mutation away from smelling disease, or navigating by magnetic north. Most pseudogenes accumulate so many disabling mutations over hundreds of thousands of years that reactivation becomes essentially impossible. But it does mean the story isn't necessarily as final as on or off. What's not speculative at all is this. Those unexplainable gut feelings people describe, the sense of being watched, the sudden urge to look over your shoulder, the instinctive unease in an unfamiliar space, those may be your brain quietly processing subtle sensory information you're not consciously aware of, using systems that are far older and far less understood than most people realize. The code is still inside you. Buried deep in your genome, mostly silent, is the fading blueprint for senses your ancestors may have depended on to survive. So here's the question worth sitting with. If the modern world went dark tomorrow, and survival once again depended on reading the invisible signals of the natural world, would any of those ancient instincts wake back up? Or have we traded them away for good? If this made you look at your own biology a little differently, subscribe, because your genome is still full of stories like this one, quietly waiting to be